Hello everybody, welcome to our next video. This one is for Wednesday night for Thursday's lesson. What we're working on today is volume, and this is something that we've covered in the past, and so we just want to make sure that you guys have a good understanding of, we've done length, we've done area, so we've done perimeter, which is the distance around an object. We've done area, which is the distance it takes to cover an object. Now volume is how much it takes to fill up an object. And so we're going to talk about the sandbox on this next page here. But first, a real quick reminder of volume. The volume of a solid object, such as a brick or a ball, is measured on how much space it takes up. Okay, the volume of a container, such as a freezer, is how much a container will hold. The volume of a 2 cubic foot freezer is much smaller than a 6 cubic foot freezer. So volume is measured in cubic units. These over here are a good example of what a cubic unit is. This is a cubic centimeter because it goes a centimeter here, a centimeter here, a centimeter here, centimeter deep, but it's like a cube. That's why it says cubic centimeters, and that's what you use to measure volume. This is a cubic inch. An inch here, an inch here, an inch back. All of them are an inch. We could do a cubic foot, where it's a foot on each side, a cubic yard, where it's a yard on each side. We could do a cubic meter, where it's a meter on all the sides. Now, volume is really helpful when you're dealing with how much water it would take to fill something, or how much sand you need for a sandbox. So I'm going to read this to you real quick. The volume of an object can be very useful to know. Suppose you wanted to buy sand to fill an empty sandbox. To estimate how much sand to buy, you would measure the length right here, the width right there, and the height. Now that should be familiar to you. We talked about measuring the length times width times height. We measure the three things together, and three things we say it's cubed, which is why we have the cubes before. You will then use these dimensions to calculate how many cubic feet or yards of sand you need to order. You can do some calculations to figure out how much concrete you need to buy for a patio, how much gravel to fill in the backyard. So this is something you would actually use in real life. Mr. Peralta needs to do that in his backyard right now, and so that's something I'm going to have to figure out. Capacity is something you use every day that you'll study more in 5th grade, but especially in cooking. You guys drink gallons of milk. You use quarts and pints and cups. We've talked about Gallon Man in here, where you have 2 cups in every pint, 2 pints in every quart, 4 quarts in every gallon. And learning how to use that to figure out your different measurements. Here's some on the side to make sure you know capacity of. It's really how we use to measure volume and how we use to measure liquids. And that's kind of the same thing, how much space something takes up. So why is the picture on the sandbox on that page? What was the point of it? That's right, to fill the volume, to how much it takes to fill the sandbox. I always use the analogy here in the classroom. If we wanted to go and measure a border for the classroom, we would measure around the classroom. If we wanted to find how much it would take to put carpet on the floor, we'd find the area of it. If we wanted to find out how much it would take to fill our classroom with water and make a giant swimming pool, that would be the volume of it. Okay, so can you think of any other examples where you might find volume? Let's keep going. Okay, real quick. Do it quick. On your head. There you go. Here's another one in your head. There you go. These should be easy for you guys. Here's another one. There you go. Okay, linear measurements. Linear means line. So for example, finding a distance from one point to another is usually given in standard units, such as feet or meters. If I'm measuring how long from here to the camera, we would measure that in inches and feet. Okay, but if we were wanting to find the area of something, how much it would take to cover, we usually use cubes, or we usually use squares, such as square feet or square meters. We measured our floor in our classroom when we were doing the area using square feet, because the tiles on the floor are made of square feet. Well, volume is measured in cubic units, and we've talked about that earlier. So this would be area. What's the area of the shape? Well, it's got a length of 4 and a width of 2, or base of 4 and a height of 2. 4 times 2 is 8. There's 1, 2, 3, 4, 5, 6, 7, 8. Remember, 2-dimension means flat. 3-dimension means it has depth to it. It comes out at you. So volume, we figure out there's 3 dimensions. So we are multiplying 3 numbers together. So it'd be 3 times 6 times 4. Well, 6 times 4 is 24. 24 times 3 is 72. There's 72 blocks in here. The volume is it. And here's how I know. There is 24 blocks here. There's 6, 12, 18, 24. And I have 1, 2, 3 sets of 24. 3 times 24 would give me 72 blocks. All right, here's a good example of here's a centimeter cube, and the big cube, where it has 10 centimeters here, 10 centimeters back, 10 centimeters back. What do you think the volume of that would be? It would be 10 there, 10 there, and the height is 10 centimeter cubes there. What do you think? How many would it be? You got the answer? It would be 1,000, because we are multiplying 10 times 10, which gives us 100, and 100 times 10 would give us 1,000 cubic units. Okay, there's other ways to do it. You could do square meters. You could write it like that, or you could do meters squared if we're measuring just an area. Okay, these are all things we're using just for area. They're two-dimensional. We multiply two numbers together. That's why the 2's are there. Okay, but moving on, we could have cubic meters, meters cubed. We multiplied 3 numbers together, so that's why they're doing that. It's 3 dimensions. That's why we have cubic inches, cubic centimeters, cubic meters. All right. We're going to do this in class tomorrow, but if you want to do some experiments with it tonight, you're welcome to. And these are all different ones that you can practice if you want to pause and try to figure it out. I will move this real quick to see if you've got the right answer. Maybe. Good. These I will move. Pause it, see if you got it. Round to the nearest tenth. Maybe. There you go. And some work we'll do in class. Thanks, guys.